Hello and welcome to Sky Grade Tutorial. In this section, we will learn everything you need to know about the laws of indices for Ssce, Neco, Utme mathematics. You will learn what the law of indices are and how to apply them. You will learn how to multiply indices, divide indices, use brackets and indices, how to raise value to the power of 0 and to the power of 1, as well as fractional and negative indices. Get ready, let us dive in immediately. What is indices? Or what are the laws of indices? The law of indices provide us rules for solving expression involving powers. Now, the word indices is the plural of index, which means powers or exponents. So that in this tutorial, we'll be using this word interchangeably. When we say indices, it means power. It also means exponents. Now, what is index? What is indices? Now, indices is the power to which a number is raised. For example, when the alphabet A multiplies itself into two places, we have A times A, and that is written as A raised to power what? 2. The A is the base, while the 2 to which the power is raised is the index. Another example is when we multiply 2 into 3 places, that is 2 times 2 times 2. We now have 2 raised to power 3. 2 is the base number, while 3 is the index or the exponent or the power. Now, to simplify expression involving powers, we first of all identify whether the terms are in the same base. We cannot use the laws of indices to simplify or evaluate questions which the base are not the same. So the first thing you find out is to find out whether the base are the same. Having found out whether the base are the same, then you need to identify the operations involved. Is it multiplication? Is it division? Or is it whatever it is? Then after identifying the operation involved, the next thing you will do is to apply the rules of indices as we are going to unveil now. Now, there are several rules of indices, but we are going to dwell majorly on about 7. The first rules of indices in this tutorial that I'm going to unveil is the product of power. The product of power is the same thing as the multiplication law. How did you multiply number that are indices of the same base? That is the product of power. It's talking about multiplication of indices or numbers having the same base and they have what? Indices. Now, the next law is quotient of power. We talk of quotient, we're talking about the result of division. So the quotient of power is talking of what? Division, the division law. How do you divide expression with the same base? That is division word law. Then the next one is the power of power. Then in this case, we're talking about the application of bracket with indices. When there is bracket in indices, how do we do it? Power of power or powers of what? Products. Now we talk of what? This is power of 0. Then there is a negative indices. And finally, we are going to discuss fractional indices. Now let us see this law in practice. Now the first one, say the law is multiplication law. That is how to multiply number of the same indices. For example, what I have on the screen now is the first one is a raised to power m times a raised to power n. Because they are in the same base, what you need to do is to plus the power. It is equals to a raised to power m plus n. So to multiply expression having the same base, you do what? You add their power, provided they are of the same base. This law is not used when the terms are not in the same base. You must first of all watch out to see whether the terms are in the same base. That is one. Now, the division law, for example, say a raised to power m divide a raised to power n. This law is saying when the two numbers are dividing themselves that are in the same base, what you need to do is to subtract their power, subtract the exponent. And when you subtract the exponent, then you have the result, provided a or the base is not equal to what? 0. Now the next thing we are going to look at is the law of what? Brackets. Law of bracket are the same. We have the power of power and the power of a product. The power of power is talking about when a power is raised to another power. For instance, a raised to power m bracket raised to power n. So what you need to do here is to multiply the two power. That means it becomes a, it becomes equals to a raised to power m times the power n. Now, the power of product is talking about bracket also. When two numbers multiply themselves raised to what? A particular power, it is the same thing as each of these number or each of these alphabets raised to the power to which the bracket is what? Raised. So a, b raised to power n is the same thing as b raised to power n times a raised to power what? N. Now the next one is the power of a quotient. Almost the same thing as the law of division, that if a is dividing b bracket raised to power n is the same thing as a raised to power n over b raised to power what? N, provided b is not equal to what? 0. Now the next one is 0 exponent or 0 power, that any number raised to power 0 is equals to what? 1. Any number raised to power 0 is equals to what? 1. The next one is the negative exponent or negative indices. Any number raised to power to a negative power is the reciprocal of that number. So that a raised to power minus n is equal to 1 over a. The next one is fractional exponent or fractional indices or fractional power. You see, when a is raised to power of any fraction, then a fraction is having two parts, the denominator and the numerator. If a is raised to power m over n, then the denominator is the root, while the numerator is the power to which that base is raised. For example, a raised to power m over n is equals to the nth root of a raised to power what? M. Another example of this, 8 raised to power 1 over 3, it is the third root of 8 raised to power what? 1. And 27 raised to power 2 over 3 is the third root of 27 raised to power what? 2. The third root of 27 raised to power what? 2. Also, another example is 64 raised to power 5 over 6 means the sixth root of 64 raised to power what? 5. Now, we are going to go back to these rules and take example one after the other. Now, the first example there is how to multiply numbers having the same base. Indices having the same base. And the first one there written in black is saying a raised to power m times a raised to power m is equals to a raised to power n plus n. And the first example in the next column gives example to this. For example, which example 1 is 3 raised to power 5 times 3 raised to power 6. This is an example of an indices that is of the same base. The base there is 3 and the power is 5 and 6. And the law of multiplication is saying that what we need to do here is to plus the powers, that it becomes equals to 3, which is the base, then 5 plus 6, which eventually becomes 3 raised to power what? 11. Now, we go ahead to example 2 in the same column, the same rule. Example 2 here is telling us 5d raised to power 4 times 4d raised to power 6. Now you discover that there is a number 5 and there's number 4. The number 5 and number 4 are not of the same indices, but the d is the same thing as d is present in the two side. In the two side. So d raised to power 4 times d raised to power 6 is an indices that can be simplified with what? The first rule, which is the multiplication rule. So what we are going to do here, number with times number, while indices with times what? Indices. That is the indices, the one that obeys the rule of indices, we also apply the rule of indices. Now 5 times 4 here is equals to 20. And d raised to power 4 times d raised to power 6 is equals to d 4 plus 6, which is equals to 20d raised to power what? 10. Now we are going to take an example again. We are going to go to the division rule. Our division rule says a raised to power m divided by a raised to power n is the same thing as a raised to power m minus n. That is, if the indices are of the same base, you minus or you subtract the powers. If the expressions are in the same base, you subtract the powers. For example, which is example 1 here, we have 3 raised to the power 12 divide 3 raised to the power 6. In this one, the base are the same. The base is 3 and 3 raised to the power 12, while the index is 12. Divide by 3, which is the base, raised to the power 6. So they have the same base. What we need to do here is to add what? The indices, which is 3. To minus the indices, which is equals to 3 raised to the power 12 minus 6. That becomes equals to 3 raised to the power 6. That is example 1 on that. Then example 2 in the next column, we have 30 d raised to the power 4 divided by 2 d raised to the power 2. This one involves number that did not obey the rules of indices. They are not of the same base, but it contains alphabet that are of the same base. The d raised to the power 4 is of the same base with d raised to the power 2. So the number will divide their number as normal. That means 30 will divide by 2. And when 30 is divided by 2, you have 15. And d will be d raised to the power 4 minus 2. And so we have 15d raised to the power 2. Now, let's go and take them one by one. We go back to the next one is the product of what? Power. The product of what? Power. How power manipulate power. It's so when a raised to the power m bracket is raised to the power n, it is the same thing as a raised to the power m times n. Let us take example for that. Example of that is 10 raised to the power 3 bracket times raised to the power 7. That is power raised to power. This one is known as power raised to power. So it becomes 10 raised to the power 3 times 7, which is equals to 10 raised to the power 21. In power raised to power, what you need to do is just multiply the indices. That's example 1. Example 2 on that is 25 raised to the power 8 bracket raised to the power 4. What we need to do is to multiply the powers, which is what? 25 raised to the power 8 times what? 4, which is equals to what? 25 raised to the power what? 32. Now, let us go and take example of the next law. The next law say any number raised to the power 0 is equals to what? 1. Any number raised to the power 0 is equals to what? 1. So that 20 raised to the power 0 is equals to what? 1. 34 raised to the power 0 is equals to what? 1. And here we have m raised to the power 0 times m raised to the power 0 is the same thing as 1 times 1, which is equals to what? 1. We go ahead to take the next rule. The next rule says that is like just like a quotient rule, says if a over b bracket raised to the power m is the same thing as a raised to the power m divided by b raised to the power m. Example 1 in this law is 3 over 2 bracket raised to the power what? 3. This is the same thing as 3 raised to the power 3 over 2 raised to the power 3. which is equals to 27 over what? 8. Now, take another example. That's example 2 on this series. That one is telling us that 5 over 6 brackets, open bracket and close, raised to power 2 is the same thing as 525 over what? 36. That is to say 5 raised to power 2 over 6 raised to power 2. Now, let's take the next one. The next one is talking about any number raised to a power of a negative power is the same thing as the reciprocal of that number. For example, that is a raised to power minus m is same thing as 1 over a raised to power what? M. The inverse. That's any number raised to a negative number is the reciprocal of that what number. Let us take example. Example 1 here says, example 1 here is saying 9 raised to power minus 2 is the same thing as 1 over 9 raised to power 2, which is equals to 1 over what? 81. Now, let us take the second example in this rule. Is saying 1 over 3 brackets open and close raised to power minus 2 is the same thing as 1 over 1 raised to power 2 over 3 raised to power 3, which is the same thing as 1 divided by 3. 1 divided by 1 square raised to 1 raised to power 2 over 3 raised to power what? 2, which is the same thing as what? 9. The last and not the least rule is talking about fractional indices. Now, the fractional indices says a is a raised to power m over n. M over n is now the fraction of to which a, which is the base, is raised. This is telling us that, the numerator of this fraction is n, and the numerator of this fraction is, the denominator of this fraction is n. Why the numerator is m? It's telling you that when a number is raised to a fraction, the denominator becomes the roots, while the numerator becomes the power to which the number is raised. For instance, this one, a raised to power m over n is equals to the nth root of a raised to power what? M. Now let us take example. Now example 1 is say 8 raised to power 1 over 3. 1 is the numerator of that fraction and 3 is the denominator. That means it's going to be the denominator will become the root, while the numerator becomes the power to which 8 is raised, and that is 3. That is the cube root of 3 raised to power what? 1. And the cube root of 3 raised to power 1 is equals to what? 3. It's equals to what? 2. And the cube root of a number is asking us how many times, what number will times itself into 3 places to give us that number. And the number that will times itself into 3 places to give us 8 is 2. 2 times 2, 4. Times 2, 8. And then we have 2. So let's go ahead The next one we are going to take a look at is another example of a fractional indices. 81. 81 raised to power 81 raised to power 1 over 2. 1 over 2 is the denominator, will assume the root, while 1, the numerator, will become a power to which the 81 will be raised. And that will give us the root of 81 raised to power what? 1. And automatically we have what? 9. Now, what we need to do, we take another example of this. Example are bound in this section on the fractional word indices. Okay? I think that is all we need to do there. So, we have been able to take examples of all the rules of indices. How to apply them from the first rule of multiplication, division, quotient rule, which is brackets, negative indices, and fractional word indices. So let us proceed to get more examples from each of these rules. Now we are going to take practical examples from each of these rules. Now, one thing you must note is that there can be indices that their bases are not the same. And so in such question, you will see they will say evaluate. When you hear evaluate, just assume that the basis or the bases in the term are not the same. When the bases in the term are the same, the question will say simplify. And whether the bases in the term are the same or they are not the same, expression involving indices can be what? Simplified, can be evaluated or simplified. For example, let us take example 1 here. Example 1 here is telling us evaluate 3 raised to power 3 times 2 raised to power what? 2. You discover that in this question, the base are not the same. 3 is not the same thing as 2. And the power is there. What we need to do here is to evaluate it. What we need to do is to 3 raised to power 3 is 27. And 2 raised to power 2 is 4. So what we need to do here is expand out this 3 times 3 times 3, 27. 2 times 2 times 2 is 4. 27 times 4 is equals to 1 over 8. This is an example of an indices that the terms are not of the same base, and it can be evaluated. The question say evaluate because the terms are not what of the same base. Let us go to example 2. Example 2 is also telling us to evaluate. And when we are to evaluate, if you see question that says evaluate, just have it in mind that they are not of the same base. The one I'm solving now, I'm about to explain, is the one in green color. Example 2. Example 2 says evaluate 27 to raised to power 2 over 3 times 3 raised to power of minus 2 times 2 raised to power 3. You can find out that 27 can be changed to, the base can be changed to 3, and 27 we have the same base with 3. But the last one, which is 2 raised to power 3, cannot be manipulated to have the same base with 27 and 3. So this is an example of an indices that are not of the same, the terms are not in the same base. And what you need to do here is to evaluate. Now we go. The fraction have the denominator and the numerator. And the denominator assume the root of 27 raised to power what? 2, which is what? The numerator, times 1 over 3 raised to power 2 any number raised to a plus a negative index is the reciprocal of that number, then 1 over, that is where we have what? 1 over 3 square. Then times it becomes 3 raised to the power 2 times 1 over 3 raised to the power what? 2. 3 raised to the power 2 cancel 3 raised to the power 2. Here becomes 1. And what you have now is 8. So the answer to that expression is what? 8. Now, let us go to another example, example 3. Example 3 here is also telling us to evaluate. And anytime we know or we hear evaluate, we just assume or we have it in mind that the terms are not in the same base. And what are we evaluating? It says 2 raised to the power 4 times 5 raised to the power 2 times 3 raised to the power what? 3. That means the 2 raised to the power 4 is 2 times 2 times 2 times 2, which gives us what? 16. And 5 raised to the power 2 is 5 times 5, which gives us what? 25. And 3 raised to the power 3 is 3 times 3 times 3, which gives us what? 27. And so 16 times 25 times 27 will give us 10,800. And that is the solution to that word question. Let's file ahead. Now we are going to take example 4. Example 4 is saying simplify 27 raised to the power 2 over 3 times 3 raised to the power n is equals to 9 raised to the power what? 5. Now 27 raised to the power 2 over 3 becomes the third root of 27 raised to the power 2. The law of fractional what? Indices. The denominator assumes the roots, while the numerator becomes the power to which the root and the base is raised. Now times 3n is equals to what? 3 raised to the power 2 times 5. This one becomes 3 raised to the power 2 because 9 is reduced to 3 raised to the power 2. Power, the rule of power raised to power is that we should multiply the power. Then it becomes 3s squared times 3n is equals to 3 raised to the power 10. And to multiply indices of the same base, you add their powers, you add their exponent. So that becomes 3 into 2 plus n is equals to what? 3 raised to the power what? 10. And what we do? 3 cancel out 3. When 3 in this side, cancel out the 3 in this side. So we now left with what? 2 plus n is equals to what? 10. Because this 3 and 3 raised to the power 2 plus n equals to 3 raised to the power 10. We cancel each other. And then we are now left with 2 plus n is equals to 10. And 2 plus n is equals to 10. We take like same together. When like same together is taken, then we have n is equals to 10 minus 2. And the answer is what? 8. Now, we take another example. This one is example 5. This is example 5. Example 5 says, example 5, the one in pink color, the example in pink color says, simplify 3 raised to the power n minus 1 times 27 raised to the power n plus 1 over 81 raised to the power n. Simple. what we first of all do, we reduce them to the same base. And reduce them to the same base, it becomes 3n minus 1 times 27 is 3 raised to power 3. 3 raised to power 3 into n plus 1. So this one, 3 raised to power 3 into n plus 1 becomes power raised to power raised to power 3 n raised to another power n plus 1. Now it becomes, that is the numerator. Then the denominator becomes 3 raised to power 4, because 3 times 3 times 3 times 3 is equal to 81. And so it becomes 3 raised to power 4n. 3 raised to power 4n, please. So here it becomes 3 raised to power n minus 1 times 3 raised to power 3 into n plus 1 over 3 raised to power 4n. They are supposed to be 3 raised to power 4n, which automatically becomes, to divide indices, you minus the power. And 3 raised to power 4n is dividing the numerator. So when if all the bases are the same, then we are going to add the powers or minus the power depending on the operation we are doing. If we are multiplying, we add the power. If we are dividing, we minus the power. And that is what we did here. It becomes 3n minus 1 bracket plus 3n plus 3, because we are multiplying, then minus 4n. Minus 4n is dividing. Automatically become 3 raised to power n plus 3n minus 4n plus 3 minus 1. n plus 3n is 4n. 4n minus 4n is 0. 0 plus 3 is 3. 3 minus 1 is what? 2. Automatically, we now have 3 raised to power what? 2, which is equals to what? 9. Now, let us go to the last question in this series. The last question says simplify. Simplify 16. That is the question in red, or what I call this is orange. And the question in orange, it says simplify 16 over 18, open brackets and close, raised to power minus 3 over 4 times the square root of 100 over 81. Now, in resolving this question, the first part of it is we are going to apply the rule of fractional indices. Now, the denominator becomes the roots, while the numerator becomes and the power to which both the numerator and the denominator are raised. So automatically it becomes the fourth root of 16 over 81, open bracket and close, raised to power what? 3. Yeah, that is it here. The fourth root of what? 16 over 81, open bracket close, raised to power what? Minus 3, which is the same thing as the fourth root of 16 is 2, and the fourth root of 81 is 3. Automatically, we now have 2 over 3, open bracket and close, raised to power minus 3. And this one is, we are going to use the law of negative indices. That says, in negative indices, we take the reciprocal. And the reciprocal in this case is equals to 3 over what? 2. And 3 over 2 raised to power 3 is something as 27 over 8. that is 2 over 3. When we take the inverse, or the reciprocal, because it is raised to a negative number, we will now have 3 over 2. And 3 over 2 raised to power minus 3 is sent as 27 over 8. So the first fractional indices, which is 16 over 81 raised to power minus 3 over 4, the result of that is 27 over 8. Then we now apply 27 over 8 to multiply the square root of 100 over what? 81. That is what we did here. And now the square root of 100 is now 27 over 8 times the square root of 100 over 81. The square root of 100 is 10, while the square root of 81 is 9. And so we arrive at 27 over 8 times 10 over 9. 27 over 8 times 10 over 9. Here you discover that 9 divided 9 is equals to 1. 27 divided 9 is equals to 3. So we have 3 and 1. And now 2 divide 8, we have 4. And 2 divide 10, we have 5. So on the numerator we have 3 times 5, and the denominator we have 4. 3 times 5 is equals to 15. Then 4 times 1 is equals to 4. So automatically the answer becomes 15 over 4. We are going to end this series of the tutorial here. We don't want to bug you with so many examples so that it will not look so boring. Now, in our next tutorial, we are going to solve past question from Ssce, GCE, Neco, and University Matriculation Examination. This is Sky Great Tutorial. Our channel is Jonah Beecroft Obi at Jonah Beecroft Obi, and our telephone number, also a WhatsApp number, is 080-3554-2119. If you want to reach out to us, you can reach out to us through this number or WhatsApp us message. If you have any problem in comprehending this tutorial, you can reach us, make comment in the comment section, and we will respond to you as soon as possible. In our next tutorial, which is going to be in Law of Indices Part 2, we are going to resolve so many past questions so that you will be acquainted on how questions are discussed in this topic. Thank you for learning with us. Well,